So hello everyone, this is Mbot lesson 3 and you're going to do the project in a group, and on these classes you're going to combine obstacle avoidance program with line follower program. So to combine it, you will do following tasks together. Task number 1, create your block in my block where it will be the written main algorithm of line follower. Task 2, write obstacle avoidance algorithm on any action, for example, when B pressed. Some hints here: if Mbot does not see an obstacle, then it will follow the line, otherwise it will avoid an obstacle. Task number 3, add speech recognition to make your Mbot understand different commands from you. Hint, completed by using blocks in AI tab. So let's do the Mbot program. First of all, you need to open Mblock application and do not forget to log into your account, and then press on the coding part plus button, and then we are going to write a code on CyberPy or Mbot tool. So we press on this one. If you have update button, you can update it, so it's gonna be a new version, and then press the tick button. So after all, you will have your Mbot. You need to add following extensions. So you need to download Mbot Shield 2, the extension, add it. After all, you need to add ultrasonic sensor 2. After that, you need to add quad RGB sensor, and you should add these 3 extensions. Just check it again in case you didn't add anything. So Mbot Shield 2, ultrasonic sensor 2, quad RGB sensor beta. So for now, let's begin from finding event and when CyberPy starts. This means when your bot starts just working, when you turn it on, we just need to set up some variables. Like let's make a variable which called base power, and for all sprites, and another variable which will be called KP for all sprites. And now you have 2 variables. Let's set them. So I just drag these 2, and one of them gonna be KP, one of them gonna be base power. So let's make this one as a base power, let's make this one as KP, and the base power we need to set as a 30. So you set as a 30, this is little mistake here. You set as 30, and KP you set as 0.8. So okay, this is beginning of the coding. You set it to do following line part. As you remember, we add these variables when we done line follower part. Now, since we are doing task 1, which is create your block in my block where it will be the written main algorithm of line follower, we need to create your own block where will be done line follower application, line follower algorithm. So we're gonna let's call it line follower. Okay, we just created. So we have this one, we drag it here, for example, and let's complete it. So you should remember that we have done a line follower algorithm, so it is not really hard. We just need to implement the same algorithm, same formula to this function. So what we need to also create new 2 variables, which will be left power and right power. So left power, and don't mix it up, left power, and you create right power. After creating these powers, like these variables, we need to set them up, of course. We need to set them. So you drag 2 sets to the define line follower, and we change one of them left power, one of them right power. Make sure that you write correctly, because this is really important. And now follow my steps. First of all, you need to get operation, you go to operations, you get minus here, so minus, and you get variables, you put base power minus, and here you need to add multiplication, so you go to operation, multiplication, and here you add kp, multiply the quiet RGB sensor deviation. So here we go to variables, we get kp. As you remember, we already set them up in the when CyberPy starts up. So when the CyberPy starts up, these already variables settled, so we don't need to set them again and again and again. This just make our program optimal. So afterwards we need to find quad RGB sensors, and we go to we need to find exactly deviation one, this one. So we get this one and put it here. So right now we have the same formula which we used in the line follower class when we've done line follower application. And now we need to set write power. So first we need to add operation which is multiplication. Here we write -1 as it gonna works differently, and we need to add plus, or a plus. So here's we add adding, and we on the left one we add variable which is base power. We add base power, and we need add multiplication. So we get multiplication, and here we use the same one, kp, and quad RGB sensor deviation. So this is our basics algorithm, and now we need to use these variables, of course. So we go to Mbot, this one, I think this one, here, and we need to set rotation power. So we get encoder motor EM1, which is left power, of course. So we get cancel variables, left power, and here we add right power. However, we can put it like that, but our program gonna like our bot gonna move right left because it's too fast. So right now we can little bit fix the speed of the bot. So I prefer to divide it to 1.75, 1.6, 1. Whatever, like around this number. It would be better because our program gonna be not so fast, and it's better for the detection algorithms in the further. After you finished this part, don't forget to name your project. For example, let's say like I'm gonna call it line follower and obstacle avoidance, just in so fast, and press save button. Yeah, don't forget to save your code every time because you might lose your progress. We have complete first task, which is create our own block. So we created our own block where we implemented line follower algorithm. Right now it's not gonna work since we didn't do anything here to make it working. And now let's do task 2, write obstacle avoidance algorithm on any action, for example when B pressed. So let's get when B pressed. Yeah, this B is like play, so I would like to set it like that. So when B pressed, and now we need to make it working. So we need to combine line follower with obstacle avoidance. How it gonna work? So if you check your worksheet 1, it's written there. It's like hint there for you. If no obstacles in 8.5 centimeters, then follow line. If there is an obstacle in 8.5, avoid obstacle. So it's pretty simple, but since still it needs some thinking about that. And let's first make the forever loop. Since it needs to check it forever and forever, we add it to forever loop. And now we need to add some if else operation. So now we need to check whether our obstacle close or not. So yes, if you remember, we usually use sensor. We use ultrasonic sensor usually for checking obstacle avoidance. So let's get this one, as you remember, distance to an object in centimeters, but we cannot put it like that. What we need operations. We need to check whether it's close or not. So we put it here, and if it less than 8.5 centimeters, then what we need, if it's less than 8.5 centimeters, we need to avoid obstacles. So here in this part, in the top part, we need to avoid obstacles, but we don't have algorithm of avoid obstacles. We have line follower algorithm. What we if there's no obstacles in 8.5 centimeters, we need to just follow lines. So we just go on my blocks and follow line. That's we need to do. Right now, let's remain it like that. Don't forget to save it, and let's try to do a third task, like prepare something like we prepared for the second task. We already done first task, we prepared code for the second task, and now let's prepare some code for the third task. So what we need AI to connect to Wi-Fi. So let's add a connection to Wi-Fi into the when CyberPy starts up. So we need to write here, and let's write my Wi-Fi, which I usually share with students, with the password. The name of Wi-Fi is a room, and this is a password. So password for Wi-Fi is 874710638870. Okay, this is the password. So this is the variable. So what we have done for now, we have implemented main algorithm of line follower, and then you get an idea how to combine line follower with obstacle avoidance. So we have like basics of that, and you have like kind of idea, you can think about that for a while, and then also you used all extensions we have studied. So you used Mbot extension, you used ultrasonic sensors, and you get quad-RGB sensors. Also used AI also actually. And what you've done else, you connected to Wi-Fi so that it will help us add some artificial intelligence features to the bot in the future. So it's gonna help us to add some AI stuff like speech recognition or. After completing this part, don't forget to save it. And right now I would like to connect to the Mbot and show how it works right now for a while. I think you should see it, that it will not gonna avoid obstacles. So let's just check it out, and just gonna see. Let's first connect to the Mbot. After connecting, back to the coding. So here, let's just predict what's gonna happen. Is it gonna avoid obstacle or not? Of course not, because we didn't write anything here. We didn't write obstacle avoidance program. It's just gonna follow line, and that's all. Let's see that how it's gonna work. So this is Mbot, and this is a map. Right now we wrote the code of just line follower, but I put the obstacle. And do you think it's gonna avoid it or not? So let's check it. Right now it's working as a line follower program as it worked before. This is much bigger map than it was before, and of course it is not avoiding it. Our bot not avoiding the obstacles, as you know. And now let's fix it. Let's add an algorithm of obstacle avoidance. To do so, we need to go to the Mbot to chases, and we need to add again the block with the power. So add here in this part, we're gonna do the obstacle avoidance program. So here we press 0 and 0. So we need to do it to avoid any problems with wheels and obstacle avoidance. So let's go further, and after what actually should do our program? It should stop when it sees any obstacles. So when it's gonna see, it's gonna stop the program, stop the wheels, and then turn any right or left. And let's do it right, for example. It needs to turn right on any degree. I'm gonna put it 70 degrees, and it needs to, again, we need to ensure when it's turning, stop their wheels after turning right. So we just put 0 and 0 again, and now it needs to make an obstacle avoidance program, so with certain percentage. So we put on the left one, we put 30%, for example, and here we put -55. Actually, in this one you can play with these numbers, in here, because it might work with also different numbers, like whichever you want. In this case, it's gonna avoid obstacle, but right now it's not gonna avoid. Right now, the program we're gonna just push your bottle. So let's see what it's gonna do. So after uploading the program, we can see that we add some obstacle avoidance, but it's not avoiding the program bottle. It's just pushing it. Why? Why it's doing like that? Let's check it. It's all because we need to add wait for a while. So you just say to the bot, hey, calm down, wait a little bit. But still, it's not enough. We just make it wait here, and also we need to add wait until something. So wait until, but what we need to wait? We're using again q_GB sensors. We need wait until it sees the line. So wait until RGB detector detects line. So then it will continue to line follow. So after doing this, it's gonna do all the parts and then make an obstacle avoidance for a while, and then work until keep following this program until it finds the line. And when it finds the line, it's gonna continue to follow the line. So this is actually line follower with obstacle avoidance program. Let's upload it, and never forget to save it. Now let's check how it works, our program right now. So Mbot. Oh yeah, it's avoiding the obstacle. Great. So for now, we have done our two main tasks: creating line follower, combining them together. So we can already combine obstacle avoidance with line follower. We've done main task. Now let's add speech recognition. Since you remember, we have added this as connection to Wi-Fi to do speech recognition part, and let's update it a little bit. So to make our code correct, or see that we already to modify code that ensure Wi-Fi is connected, let's set some printing. So let's go to display and print here. For example, let's print here connected, but not here. Actually, we don't need this one. We need to set print size. Let's make it middle. Connect to Wi-Fi. Let's add if operator. So we're gonna add if operator, and if go to AI network connected, we print and move to new line that we're connected. Yeah, we're connected. Great. So let's modify this code like that, and our task is to add speech recognition. So let's make the code. We're gonna say go, and it's gonna go instead of pressing every time B button. So let's add a new block. So we add my block. Let's call it main code, main code, because it's actually our main code of our main program. So let's call it like that, and we remove it from here, put it here. So right now we have like additional function for main code, and then we just put it here, and it's still gonna work manually. Right now it's still gonna work manually. If you press B, it's gonna work, but still we have this one in addition. So now let's go further. Let's add when we say go, that it's gonna work. So let's add, if we connect it, then we need to go to AI, recognize word in English, of course, but if you wish you can add Chinese version, but as I recommend you to add English one. And now we need to get variable. So we need to get operation if, and if we need to get operation or. We need to get equal here, oh oops, something like that. And here we need to get it like go, okay, or go that, because it might be some mistakes, or like when it checks your voice, it sometimes add like dot in the end, full stop. And last but not least, we need to add speech recognition result, and when it's okay, and when everything is fine, we just need to make main code. So that's done. Let's save the code, let's upload it, and yeah, let's check it. Right now it's already connected. I press this one, go. We should wait a little bit because the program works a little bit. Oh, why it's turned around, but that's okay. We can put our bottle here and check it there. It's okay, I guess. Wow, it's working with our speech recognition. It recognized our speech and following it. Great. So now you should know that it's gonna wait for a couple seconds, and you should be patient because recognition result works long on these devices, so it's okay. So what we have done, we have completed combining line follower with obstacle avoidance. Understand how works obstacle avoidance algorithm in a line follower program, and we made a program works with a voice command. Right now I can announce you some extra tasks which you can do at home or on the class. It depends on your willing to do that. Build separate block for obstacle avoidance algorithm. This is the easiest task, I think. The second task is build another type of obstacle avoidance algorithm. For example, avoid obstacle rectangularly or triangularly. So let me explain this task. In this class you have done obstacle avoidance algorithm which avoid obstacle circle, in the circle form, but you can do it with another form like rectangle with the square, or triangle like triangularly. And third task is add more voice control commands to the bot. So you can add some extra voice commands. For example, on command circle avoid obstacle around, and on command square avoid obstacle rectangularly. So you can combine this third task with second task together actually. Okay, well done. So let's check the code again. Yeah, And if you have problems with AI, this one, let us know. Of course, we're gonna help with you.